Hello, everyone. Welcome to the fifth GeoGebra webinar in this series on our recent release of the grades 4 through 8 math resources. Today, I'm very excited and happy to welcome a guest and a friend of ours at GeoGebra, Steve Phelps. He has been a long time GeoGebra author, contributor, ambassador, and he's one of the people I know who's very passionate about probability and statistics. And so I'm glad that he's able to hop on today to share a little bit about using GeoGebra for probability and statistics, incorporating some of his extensive knowledge base in with this. There's a smaller group of us today, but I would still love to hear just a little bit about you. So if you wanted to put in the chat and just share who you are, where you're from, what subjects you teach. You can even drop in social media, and and then feel free to just continue to type in the chat, and we'll keep an eye on it. But yes, Steve, why don't you take it away?
Oh, thanks, Monique. Thanks. I'm glad you guys are all here. They asked me to do this. I'm thinking, I don't know. I like all of the stuff that is on all of the new resources they've been creating. They're really high quality, super engaging. And as I started to tinker with them and play with them, they were better than I originally thought. So kudos to the folks who are putting these things together because they really are nice. So yeah, we'll talk a little bit tonight. We'll look at some probability and statistics resources that are there in the resource area on the website. We'll try a live exploration in GeoGebra Classroom. The ideas that I would like to share with you for the classroom is kind of like my instructional arc for teaching probability topics. And this is not original. I've modified it, but intuition, simulation, revision, and calculation. I find that when teachers, especially young teachers, go to start teaching probability, they're very focused on calculation, but they miss the intuition, kind of like, what does your gut tell you about this random scenario? And then taking advantage of a software tool like GeoGebra to build simulations to let kids test their intuition and then to give them a chance to revise. Most things are just calculate, calculate, calculate. And in this instructional arc, I think calculation comes last. After we explore the GeoGebra resources, we'll come back. I'll share a couple of resources that I've used in the past, things I've created when I taught stats years ago. I'm no longer a stats teacher. This is the first year ever where I'm teaching more computer science classes than I am math classes. So the resources, I love all the Zoom windows. They're always in the wrong spot. The resources of GeoGebra.org/math. These GeoGebra resources just looks different and feels different. This is really a nice place to go. A nice place to go. I wonder if I click on that. Will it take me there? It will take me there. I'm so excited, but I wonder if my sharing window, I wonder if this window is actually even shared.
Yep, I can see it.
That is fantastic. I wasn't really sure if it would share. So here are the GeoGebra resources. Love all these things. And I'm hoping, fingers crossed, that they will add some equally rich things for high school statistics like AP statistics and things like that. So I'm hoping at some time they will come down to that. That'd be fantastic. But still, this is pretty good what's there. And so we are going to focus more on the probability things. And what I did is I kind of just went through and I was thinking about the teachers that I work with. I'm also an instructional coach and a instructional technology coach in the district that I work at. That's what I spend my mornings doing, working with junior high teachers and high school teachers. And I was trying to think like, okay, here are the things that my junior high teachers are starting to work on. And so those things kind of revolved around box plots and working with box plots. So I chose some things that are going to be more box plotish, if you will. So one of the first resources we'll do is this finding the median of a data set. And the more and more I played with this, the more time just went by, so if you will. So I'm going to escape out of this for a second. And that is, oh man, I've got a bunch of tabs here. I have a bunch of tabs. So is it that one? No, it is. Is it this one? There it is. Okay, I was only one off. I was only one off. So this is the finding finding and working with medians. And I do like this. And this would probably be a pretty nice activity, I think, to kind of um, put on a GeoGebra classroom so you could see what a lot of kids are doing, and provide resources that way. I created an activity similar to this, where the points were on a line. This, though, setup has kind of grown on me. And so notice, like, changing these points around aren't doing much. But I think this is the thing that's cool. I love how it kind of sticks like glue. But moving points around, what is the smallest median you could make? What is the largest median you could make? Is it possible to have all these points lined up in a line? So a lot of different things that you could explore about medians and how the median kind of is splitting your data set into two parts. And there's one way down here at the bottom, because you know how these zoom toolbars work. The zoom toolbars are always in the wrong place. I can increase the number of data points if it's an even number of data points, an odd number of data points. So a lot of things you can do with that. Love this feature. That's a really nice little app to play with. And I think the next one, when we get to this next one down here, this is a practice resource. So that was an exploration resource where kids are literally just kind of exploring, getting to feel how the median works, and maybe giving your students some kind of tasks to accomplish while they're in the GeoGebra classroom, and you are actually kind of seeing their screens. So here's one for them to practice drawing box and whisker plots in kind of a digital setting. And this is another, again, I think this also lends itself nicely to GeoGebra Classroom, because you can see exactly what the kids are doing and if they're making progress or if they're not making progress. So I'm going to close that tab out. And there is the drawing a box and whisker plot. So, oh my goodness, I really do like Zoom. It does bring all of us together, but all of the Zoom windows are always in the places where I don't need them. So you've got, I can sort my numbers, which is a nice feature. And I do like the animation. And then drag. Okay, I'm gonna drag to start and I'm gonna see what happens. And so I know this one's got to come out here to 37 somewhere. And then I'll drag the, I wonder if I'm afraid, what if I don't get it correct? This has a really nice drag behavior. I really, really like this drag behavior. When I first did this, I kind of stopped where like a below 5, not thinking I have a scale that I'm also dealing with. And I almost made the same mistake over on the right, where I went all the way out to where 37 was, forgetting that, no, I've got a scale that I've got to work with. So I've got to align that whisker on the right with 37, and I need to align this whisker with 5. Oh my gosh, now we've got to figure out where the median is. So I'm counting in. You cannot see me with my fingers, but I'm counting in 2, 3, 4, 5, 6, 7. It appears that 19 is my median. And if 19 is the median, then the lower quartile is between 12 and 15, which 15 and 12, that would be about there, I think. And then between 25 and 27, I got that 26. Now I'm wondering if I get this wrong, this could be embarrassing. Well, okay, so it's embarrassing. I wonder how they define their medians. I wonder if it includes 19. I wonder if that should be, oh, wait a minute. My 19 moved. That's what it was. My 19 moved. Or maybe I never had my 19 in the correct place to begin with. So that is a cool drawing. I really do like this one. I really, really like that one quite a bit. Oh, this is perfect. This is absolutely perfect. Just checking time, just checking the time, making sure, because Monique and I talked. She knows this is past my bedtime, but I could talk about GeoGebra till midnight if we had to. So let's look at one more in GeoGebra Classroom, comparing box and whisker plots and dot plots. So if you would like to give this a try, if you would like to give this a try, oh, not that one. I'm going to delete the ones I don't need open anymore. And that means eventually what will be left will be the ones that I do want out. So if you would like to join this classroom, if you go to geogebra.org/classroom, and if you were to type in this code, you've got this activity that you can actually play with. And I wonder if I can put that, I should put that in the chat. We're going to find out if that
No
copied or not.
worries. I can paste that in the chat for everyone.
Oh, thank you. I just opened it up and I saw it there and I'm thinking, it like thought it knew what I was thinking. I've I've just recently had gotten a couple of teachers to engage with GeoGebra Classroom. What I like about all of these new resources that they've made is that they do seem to be tailored to GeoGebra Classroom. You'll notice that they're just two tasks. If I made something, they would be like 25 tasks. That would be terrible. But so all of these things that I notice about the resources that they put out recently is that they do seem tailored to the GeoGebra Classroom environment. And so I've got some of my teachers I've been working with to try to make those. And so let's, I think, so this is a very much like a kind of, it's kind of an exploration, but you would probably need to provide your students with a little bit of instruction, maybe. I know there's instruction there, like let's build a box and whisker plot and a dot plot, but you may want to give them some suggestions like, can you build a dot plot where the median is 5, but there are no dots on 5? So that is a very cool box plot, man. That's a cool box plot. I've never, oh man, here we go. This is why I'm not going to make my bedtime tonight, because now I wonder if I can do this. Okay. On the start again. I'm going to put, things that, okay. Why? Okay. I know why it's doing this now. So the lower quartile, the upper quartile and lower quartile are the same as the max and the mins. Got it. Thinking about that. Got it. That means I could place numbers on 5 and it wouldn't change my box plot at all. But if I had 1 on 4, oh, that's not what I thought would happen. And I'm sure there were instructions there. Construct a dot plot, explore the associated, discover connections between the data displays, measures of center, interquartile range, and IQR. Yep. So these are all, this is just, yeah, I'm happy my teachers are giving this a try. They usually use something else. And they didn't even realize that you could do these things in GeoGebra and actually see what kids are doing. But these are super engaging activities. And I think they're perfect for that kind of junior high age group or late elementary school age group if they're working with box and whisker plots. So let me share three more personal resources that I have used, that I've created and used. And one of them I will share, it's coming up where March is my favorite month of the year. I'm going to toggle back up to the very start of this, almost to the very start of the presentation right here. And so these links do exist, but this idea of the instructional arc of intuition, simulation, revision, and calculation. I've got three links over here on the right-hand side. The first one will be ice cream prices. And this is a nice activity if students are kind of just starting to work with dice probabilities and rolling two dice. And you'll see now, this is an older activity because it's intuition, simulation, mathematics. And then I sort of modified it to include revision. Um, After I'd also modified mathematics to be calculation because it all fit together. But the idea behind this activity is that you have 50 cents in your pocket and you want to buy an ice cream cone, and the owner of this ice cream shop offers a random price by rolling two fair six-sided die. And the larger of the two rolls is the tens place in the cost, and the smaller dice is the units place in the dice. So for example, I could pay 41 cents for an ice cream cone, but I can't pay 14 cents. So this is a nice activity, but it has some very counterintuitive kinds of outcomes and results, but there's a lot of different things that go there, and it kind of like plays on the what if not. So what if we had three dice instead of two? Or what if we were looking at the average price instead of the median price? Or how likely is it that I get free ice cream? Another one that I've used, this is more of a search page. Like if you search for simulations, Phelps, this page will probably pop up. Now, years ago, well, that's really not years ago. What is it? 5 years ago? I guess that is years ago. I taught AP stats for a long time. I still love AP stats. We've got a great stats teacher at the school I'm at now who's right in the room next door, and we are always collaborating on things and on simulations. And so what I've done with these things are I have created some simulations based on some of the prior AP released statistics questions. And so there's the one sun policy, there's a lotto ticket simulation, a housing simulation, extroverts simulation, a tattoo simulation. So all of these are involved. If I will go to this one here, and this is probably the wording for the AP question, all that stuff there. And this gives you a chance to kind of experiment and play by simulation. And then at the bottom, to do more exact calculations with a binomial model. And this is what I'm really most excited about, March randomness. I've been doing this for a couple of years now, and with all of the teachers. And what we do is that this goes for 12 days over the course of 3 weeks. We are starting a week from Monday. And the idea is I pose kind of random questions, and kids make a stat coin wager. Their wager could be anywhere from 100 stat coins to 400 stat coins. And they can only make so many of those bets. Like I can't just always bet 400 stat coins, but based on how confident they are in their guesses. And so what these are like is I will scroll down here. So for example, this would be a question in March random list. You flip a coin 4 times. Will you get heads exactly 1 time? So I know what the simulations would tell you, and you could work on calculations, but what I end up doing is I go home and I record myself actually doing this experiment. And the experiment determines if the students are correct or incorrect, because they're just going to answer yes or no to this question. Yes, I think it's going to happen. No, I don't think it is. And then I do the experiment. But here's my intuition. I can play with this with kids. And what is your gut telling you about this? As I keep flipping 4 coins, Does heads ever occur exactly once? And if it's so, does it happen quite a bit? And then here is the simulation where I can simulate 100 trials of this little question. And we can see the table's updated. This is only 100, so I know that 28% of the time I'm getting one head. And then we would like to kind of jump to in this, there's not time for a revision because we're posing the question, and this is kind of an instructional material that accompanies it on the next day when we reveal the answer. But here is the calculation in a quite different way, where I'm expanding a binomial that is raised to the fourth power, and the coefficients. So over here, this 1/4 ht to the third, that 1/4 is the probability that I get one head and three tails. So it's using kind of a generating function idea for the high schoolers. So those three resources are there if you like to explore those further. But this is, I love the GeoGebra things, love the new resources that they've been putting out. They are built for that GeoGebra classroom and watching what kids can do. And give this stuff a try. If there's something I can help you with, reach out to me. Most of you guys know how to contact me on social media. My stuff is all down here at the end, the last slide. I think it's the last slide. It's close to the last slide. There it is. So if you need to get a hold of me on social media, I'm usually a math tech coach somewhere on Instagram or Twitter or TikTok or Facebook. So you can find me at any of those places. All right, Monique, would you like me to leave this up for anything, or would you like me to
Yeah.
unshare?
Uh could you why don't I share my
Okay,
screen?
you got it.
Thank you.
Yeah.
Um yeah, so we are on the basically just to wrap things up, again, if you have any questions, you can of course contact Steve directly, and I'm sure he's like excited and happy to help. The next webinar will be in March, and that will be the last webinar that we're doing in this series. It's going to be on measurement. So it's again on a Wednesday, 9 p.m. Eastern time. And it will be recorded. And so just keep updated on social medias for some of those links to register. Um, the this presentation will be available. You can use this QR code to just register to get a copy of the presentation, and it'll include all the links that Steve showed and shared. And again, all of these resources are on GeoGebra. They're OER, so they're free, and you can combine and mix everything that you've seen today. Um, but otherwise, if you have any other questions or you have feedback or suggestions about these resources, you can contact community@geogebra.org. I am happy to read all of your comments and take that into account as we develop and continue to develop new resources. But otherwise, thank you so much for your time today, and hope to see you next month. Right.